What's up, y'all? I'm Tom, and this is Like a Math Class. And this is Blanca. She's like a math dog. In this video, we're going to talk about how do we integrate e to some f of x power, so some function within an e function. How do we integrate that? Let's get to it and find out. So U-substitution with e to the x. Well, you know what? First off, I actually don't like that e to the x. I'm going to call this e to the f of x. So I'm going to say what's happening if we've got some function within the e function. So here we can see that this piece here, this is going to be our u. That's the inner piece. And if you don't know the inner piece, that's nice. If you don't know about U-substitution, make sure you check out this video where we go through the whole foundation of what U-substitution is all about. Okay, our inner function is going to be u. So u is going to be 3x plus 7. So the derivative of u with respect to x is going to be 3. Now, as we did in our other video, we're going to multiply both sides by dx, and that leaves us with du equaling 3 dx. As I start rewriting this, I've got the integral of e to the u, and now I want to put 3 dx. Whoa, 3 dx. I don't have 3 dx's here. I've only got 1 dx. So I can't substitute this in for this right here, because here's 3 dx's, here's only 1 dx. So I got to get rid of this 3. So what I'm going to do is I'm going to divide both sides by 3, and that's going to leave me with 1/3 du, and that's going to equal dx. Okay, so now I can call this piece here our dx, or this 1/3 du. All right, so that's a little different than what we've seen before, but we have to make sure that our substitutions are equal, that we can't just put in new pieces, right? All of our substitutions have to be accounted for. So this is accounted for by doing 1/3 of du. So we're going to take e to the u times 1/3 du. So when we integrate values, we're going to bring out our constant. So we've got 1/3 of the integral of e to the u du. All right, fantastic. I can integrate that pretty easy. The integral of e to the u is e to the u. So we have 1/3 e to the u plus c. All right, so we're not talking about u, we're talking about 3x plus 7. So we're ultimately left with 1/3 e to the 3x plus 7 plus c. And this is our solution. Now, I like to check my integrals with derivatives. I've always felt more comfortable with derivatives. It's the thing I learned first. You might feel the same way. You might feel that I can do derivatives really well, but this integration thing, I don't get it. So check your work with a derivative and make sure that that derivative matches your original integral. So I'm going to take 1/3 e to the 3x plus 7, and now I'm going to start by, well, if I take the derivative of this thing, the constant just comes down. I take the derivative of this outside function, e to the 3x plus 7, so that's just e to the 3x plus 7, and then I take the derivative of the inside of this function, which is going to be times 3. Well, that's nice. 1/3 and 3 simplify out, and I'm left with e to the 3x plus 7. Yay! That's exactly what I had back here. I'm good. I integrated correctly. Let's look at one that might shake you up a little bit more. Maybe, maybe not. We'll see. So here we've got the integral of e to the power of square root of x over square root of x with respect to x. Ugh. If this is our function, then this is inside of our function. So I'm going to start with that. I'm going to do u is equal to square root of x. And actually, you know what? I'm not going to do u to the square root of x. I'm going to do u to the x to the 1/2 power. So that means I could substitute in here the integral of e to the u, and then I could go over u, and then I've got dx. Let's see, does that work? Well, if I take the derivative of u with respect to x, that's going to be 1/2 x to the minus 1/2 power. Multiply both sides by dx, and what am I left with? I am left with du is equal to 1/2 times 1 over square root of x with respect to x. Okay, I don't have 1/2 anywhere up here, so let's get rid of this first. Let's move that over there. So we're going to multiply both sides by 2. So now I've got 2 du is equal to 1 over square root of x with respect to x. Now up here, I had said, well, hey, I've got u is equal to square root of x, or x to the 1/2 power. I could substitute it in there, but you notice I'm left with this dx, and oh wait, here, this is the same thing as this. So I don't want to actually overly use u when I'm substituting. So I could put u in for both pieces, but what we can see now is what's actually happening is I've got my derivative of u is actually accounting for that other piece of the u that I put in my first step. I'm trying to follow what your thought process might be. As you get more practice in this, you're not gonna make this kind of mistake. So if I were to do this again, I would start by saying, all right, I'm gonna take u equals x to the 1/2 power. And then I would immediately go to, all right, I'm gonna take the derivative of this with respect to this, and I'm gonna go through this whole process and simplify this down before I even start substituting things in up here. So the reason I do that is because as I start rewriting this, I could even break this out into two pieces before I started substituting. I could say e to the square root of x times 1 over square root of x dx. You might not naturally think of that. Maybe you do that after you start doing your U-substitution. But the thing is, what I'm saying is, the point I'm trying to make is, get to the point. Do your u, do your derivative of u, and then start rearranging to see what happens, what can fit back into your original integral. So as I've done that now, I can see I'm going to have the integral of e to the u, and all of this is all of this. So this can be replaced with 2 du times 2 du. Again, just like before, I'm going to bring my constant out. So I'm going to have 2 times the integral of e to the u with respect to u. All right, so what does this look like? Well, the integral of e to the u is e to the u plus c. So I should end up with 2e to the square root of x plus c. That should be my answer. Cool. Let's check it with the derivative like we always do. All right, so the derivative check. We've got 2e to the square root of x plus c. You don't really have to put this because we know that c, that constant, would go away, but I put it in there. So e to the square root of x. Well, let's move that back to a power again. So 2e to the x to the 1/2 power. So the derivative of this, I'm going to bring my 2 down, a constant, times the derivative of the outside, e to the x to the 1/2. That's just going to be e to the x to the 1/2. So that's going to be times the derivative of the inside, which is, you bring the 1/2 out. So we're going to have 1/2 times x to the 1/2 minus 1. Okay, our 2 and our 1/2 will simplify out, and we've got e to the x to the 1/2 power times x to the negative 1/2 power. Let's put these back into square roots, and we've got e to the square root of x over, because we've got a negative square root there, square root of x. And we are back to our original function. So there we go. Doing integrals or U-substitution with e functions, it's got some tricks to it, but you'll get there. As with everything, with practice, you'll get there. If you found this helpful, give me a thumbs up, like the video, and I'll see you in the next one.